Okay, we are beginning talking about operations on functions. So this is the real essence of section 2.6 and the typical operations, addition, subtraction, multiplication, and division, but then also one that's kind of unique to functions, something called composition, which you've done before, but we won't. That's when you take one function and put it into another. We won't do that today. We'll save that for Friday. But the homework is out here for this, so feel free to give it a try. Today, we're just going to talk about adding, subtracting, multiplying, and dividing. So here we have two functions, f and g. They both happen to be lines. And we're going to find the domain for all of these combos, for all these results of adding, subtracting, multiplying, and dividing. And the rule that you have to keep in mind is that when we are combining two functions, the result has to be a domain that both functions agree on. For example, if g can never, if 2 isn't in the domain of g, then when you combine g and f, no matter what you're doing, multiplying, adding, subtracting, or dividing, that combo, the result, 2 can also not be in that domain. Even if it's not clear, even if by looking at the end result, you would think 2 can go in there, you're not dividing by 0 or anything. You have to look at the whole history of the problem and take into account both functions' individual domains, and you kind of have to respect them both. The bottom line is you need a domain that will satisfy both, and then I'll talk more about that later. Here it's not too critical because these are both lines, and lines always have a domain of all real numbers, so nothing really too much to think about. Well, f plus g of x is how you read this, and you could rewrite it as f of x plus g of x. It is not distribution. It is not. Don't think distribution. It looks like it. I get it. But distribution is a combination of multiplication and addition, and you are not multiplying anything here. What this equal sign is really saying is that f plus g of x is the same thing as taking that input x, putting it into f, putting that same input into g, and then adding the two results. So it looks like distribution, but it isn't. Anyway, but this separating it like this can really help me simplify this problem. If I want to take f of x plus g of x, well, I know what f of x is, and I know what g of x is. So I just add them up. 3x plus this gives me 1x plus 5. And this happens to be a line, another line with domain of all real numbers, but that really only exists because individually they had the domain of all real numbers. And again, I'll talk more about that later. F minus g, same thing. You just take one function, subtract the other. Subtraction is very slippery, so be careful. You're subtracting the entire function of g, which happens to have two parts. So you have to subtract both. So you need parentheses. So this becomes 3 plus 2 and then minus 5. So 5x minus 5. Again, the domain is all real. F times g of x is the same thing as f of x times g of x. Now here it should be clear that we're not distributing, because in algebra, we don't distribute multiplication over multiplication. It's just, think of this as just a way to separate them. So I know what f of x is, I know what g of x is, and I can multiply them. That's an Algebra 1 problem. I just have to multiply according to the rules. Now here we're multiplying, and here we have addition, so now finally we have distribution. I'm really distributing 3x to both of these terms, and taking my time and being careful to distribute and add correctly. So I get negative 6x squared plus 15x, and again, the domain is all real. But things change here. Division. And the reason why it changes, you're dividing a line, which has domain of all real, by another line, which has a domain of all real. But the very fact that you're dividing should alarm you that you cannot divide by 0. So now we have something that we have to be careful of. Negative 2x plus 5 cannot equal 0. So showing me your scratch work would be much appreciated. You could set negative 2x plus 5 equal to 0 and solve. You would discover that x equals 5 halves. So when x equals 5 halves, negative 2x plus 5 equals 0. And that's a problem because you're dividing by negative 2x plus 5. So the domain of this entire result is every real number except for 5 halves. And this is how you write it as an interval. The extremes are negative infinity to infinity, but you're hopping over that 5 halves value. Now, we are going to add these two functions, subtract them, multiply them, and divide them. And we're going to find the domain for all 4 of those results. So first of all, adding f and g. I can separate them into f of x plus g of x. And I know f of x has a domain of everything from negative 12 to infinity. As long as my number is negative 12 or bigger, I'm taking the square root of a positive number, or I'm taking the square root of 0. G of x has a domain of negative 1/3 to infinity. As long as x is negative 1/3 or bigger, then I'm taking the square root of a positive here, or the square root of 0. So now here we have domains that have to kind of get along. Our result has to have a domain that will satisfy both of these. So I drew the domains on a number line right here. This top one is from negative 12 to infinity, and the bottom one is from negative 1/3 to infinity. Well, the only domain that would satisfy both would be this red one, from negative 1/3 to infinity. And you're taking this set, this top blue set and this bottom blue set, and you're really finding what x values do they have in common. And in math, we call that the intersection. And you know the union symbol of the U? The intersection symbol is a U turned upside down. But the intersection of these two domains is the domain of our result. It happens to be the same domain as G, just happens to be the same domain as G. And I'm going to add f plus g. And this is a great problem because there's not much to do. We can't really simplify this. They don't have the same radicand. So I just leave it here. This is the sum of f and g, and here's the domain. Now, f minus g, similar story. You can't simplify them. Make sure there's a minus sign here. Same domain for the same reason. F times g. F times g, now here you can simplify, because when you're multiplying two radicals that have the same index, you just multiply what's inside. And you're multiplying a binomial times a binomial, which means you double distribute, and you get 3x squared plus 37x plus 12. That's the simplified version, which is what MATLAB will ask for. And again, the domain is still this. There's a real subtle point here about the domain. Wondering if I should go over it, but maybe I'll go over it a different part of class. But if you were just given the square root of this, if I said, you know, h of x equals this, what's the domain? There would be a different answer for this, because the parabola 3x squared plus 37x plus 12 is some parabola. I have no idea, but it's a parabola nonetheless, and it has a y-intercept of 12. So let's make it somewhat feasible here. And I actually know the two zeros, negative 12 and negative 1/3. So here's what that graph looks like. Let me change the color. Here's what that parabola looks like. And if the square root of this parabola, well, what's the domain of the square root of this parabola? Well, you can't take the square root of these negatives. You can't. So the domain of the square root of this parabola will be all the x values over here. So everything less than negative 12. And all the x values over here, all the x values greater than negative 1/3. But that's only if you're presented with this function right away. Like, here's the function. What's the domain? But this function is the result of this work. So it's the whole problem is considered. This is the result of a combination of two functions. So we have to take their domains individually and see what they have in common. And then that's the domain, barring any other reason, like maybe we ended up dividing by 0 or something. But this is the domain. I hope that makes sense. I can explain that later in class if that was too different. To me, it's similar of like, if I said, what's the square root of 9? You would say 3. 3 is the correct answer. But if I said, I'm thinking of a number, and if you square it, you get 9. What number am I thinking of? Well, now suddenly you have to take the square root. And because you invoke the square root, you have to account for plus and minus. So from one perspective, it's kind of like the same problem. You're still taking the square root of 9, but in one situation, you're just telling me 3. And in the other situation, you have to account for plus and minus. Okay, f divided by g, f divided by g. Well, again, f has a domain of -12 and beyond. G has a domain of -1/3 and beyond. So the domain that they agree with is from -1/3 to infinity. But here you're dividing by something. Now you have a problem of division by 0. And the x value that would make you divide by 0 is -1/3. So the domain changes so slightly. Instead of including -1/3, it is now excluded. It's everything greater than -1/3, not greater than or equal to. And it's worth mentioning too, I did simplify, which my math lab will ask you to do. So in another world, this might be totally sufficient because that's f divided by g. But you have to multiply, not by the conjugate, you're just multiplying by the denominator over the denominator to get rid of that radical down there. And then that also changes the numerator, but the good news is we already multiplied these two numerators back up here, so I just rewrote my my answer. And I get no denominator, no radical in the denominator here. Okay, 2 more slides, 3 more slides. 2 new functions, f and g. Find f times g, find f divided by g, and this is something new, f plus g of 2. And I always tell my students, if you begin with a variable, you're probably going to end with variables. If you begin with a number, though, you're probably going to end with a number. So f plus g of 2, my final answer is going to be a number. But f times g of x, my final answer is going to have some x values in there. Well, we've done these before. F times g of x is the same thing as f of x times g of x. Well, I know f of x is 3x plus 1 over x squared minus 9. And I know g of x. It's x minus 5 divided by x squared minus 9. Now, what are these domains here? The only problem with, the only real threat with both of these functions is that you're dividing by something. So you can't divide by 0. So can you see what numbers make you divide by 0? Of course, -3 and +3. So the domain for f and the domain for g are identical. They're both all real numbers except for -3 and +3. And now I'm multiplying them. That won't change the domain at all. When I multiply fractions, I just multiply across numerator times numerator, denominator times denominator. This could get a little messy, so make sure you're writing carefully and cleanly. You have to double distribute. The numerator becomes 3x squared minus 14x minus 5. The denominator becomes x to the 4th minus 18x squared plus 81. But the domain is still everything, every real number except for -3 and 3. F divided by g. The division is always the one that causes us problems. First of all, we know f, no big deal. And we know g, and now, but the difference here is that you're dividing. So not only are you dividing by x squared minus 9, that was already a problem up here. So that already limited our domain to everything except for -3 and 3. But now we're also dividing by this bigger denominator. So not only do x squared minus 9, that can't be 0, but this x minus 5 is a problem. If x minus 5 is 0, then this whole denominator would be 0. For example, if x is 5, then this is 5 squared minus 9. So that's 25 minus 9, that's 16. But this is 5 minus 5, which is 0. And immediately that's not really a problem because 0 divided by 16 is just 0. That's okay. But it's this fraction is now being divided by 0. This whole thing would be 0. So that's the problem. So x can, not only can x not be 3 and negative 3. Oh, come on. But I also have to throw into that x cannot be 5. So still a huge domain. The domain is all real numbers except for 3, negative 3, and 5. So now how do I simplify this? Because you're not going to get this right if you put that into my math lab or on the test. Always want to simplify. Do you remember if you have a fraction divided by a fraction? You flip and multiply. You take the numerator and you change division into multiplication, and you reciprocate, you flip the divisor. So it becomes x squared minus 9 over x minus 5. And luckily for us, these x squared minus 9s cancel out rather nicely. So the whole thing is just 3x plus 1 over x minus 5. Now here is a great example, because just by looking at this fraction, you would think, oh, the domain is all real except for 5, because 5 is the only problem. But that is a mistake. You have to respect where this came from. This is the result of two functions being divided. So that means the domain, not only can it exclude 5, because that's obviously a problem here, but it has to exclude any other values that gave f or g a problem. And those numbers were negative 3 and 3. So the domain for this final answer is all real numbers except for negative 3, positive 3, and positive 5. So this is how you write that in interval notation. The last bit on this problem was f plus g of 2. There's two ways to do this problem. We know that f plus g of 2 is really f of 2 plus g of 2. So you just show some work and find out what f of 2 is. It's negative 7/5. Find out what g of 2 is. It's negative 3 over negative 5. And then just plug them in. You want to add them up. So they have the same denominator. So I get to add 7 plus negative 3 is 4 divided by negative 5. So negative 4/5 is your final answer. Or the other way to do it, which doesn't really, why would anyone do it this way, but you could just find out what f plus g of x is. That's the same thing as f of x plus g of x, which is this. They have the same denominator, so adding them is not really a problem. The numerator becomes 4x minus 4. Now this right here, 4x minus 4 divided by x squared minus 9, is f plus g of x. So I want to know f plus g of 2. So take f plus g of x, replace x with 2, and you get the same answer. You should get the same answer, negative 4/5. Obviously, the one over here is the easier way to go, so you should probably do that. Last example, I hope you're still awake, because this is a great example. I love this problem because I love graphs. You got two graphs here. They both look like piecewise functions. And the blue one is called f, the red one is called g. What is the domain of f plus g? Now, how are you going to even think about f plus g? F plus g of x is all possible results of all possible y values of f plus all possible y values of g tied to their x values. But we don't really need to find that. We just need to find the domain. So what are all the possible x values that I get to do f plus g? Well, again, I'm combining two functions. So the domain has to be a domain that both f and g like agree on, that will satisfy both of those functions. So the domain of f I drew as the blue line. The domain of f goes from negative 4 all the way to positive 3. So that's the blue line. The domain of g is bigger. It expands from negative 4 all the way to positive 5. But what do these two domains really agree on? They agree on where they overlap. So between negative 4 and positive 3. Again, that's called the intersection of those two sets. And even if it was like this, like if the f happened to be way over here to the left, what domain do they both agree on? Wherever they intersect. So this x value all the way to this x value would be the domain. But as it is now, it's just from -4 to +3, just happens to be the same domain as f. So that's the answer of the domain of f plus g. It would be the answer to number 2, f divided by g, except we have to be careful. We're dividing, so you have to be sensitive to that. If you're dividing, you need to get into the habit of thinking, can't divide by 0, can't divide by 0. So f is being divided by g. And this is the, first of all, the possible domain that you're kind of starting with. But do any of these x values in this domain cause you to divide by 0? Well, we're dividing by g, and g is the maroon. G is 0 right here. When x is +3, g is 0. So +3 can't be in my domain. And over here, when when x is -4, g is 0. So x can't be -4 either. But other than that, g is positive or negative. It's just not 0. So the domain is everything between -4 and 3. So it's excluding those endpoints. What about g divided by f? What about the reverse? Well, now f is the divisor. So f can't be 0. And looking at f, there's only one spot where f is 0. It's right here. So now what x value is this? And here we're allowed to guess. It looks like, well, it looks like it's definitely 1.5, because this, I guess we can assume it's a line, but whatever. 1.5. So the first of all, for everything between -4 and 3 is totally fine, except for x equals 1.5, because that would cause f to be 0, and you just cannot divide by 0 since we're dividing by f. So my domain is everything from -4 to +3, except for 1.5. And this is how we write it. What is g of times f of 0? Remember, you begin with a number, you're probably going to end with a number. And look at the question, what is the value? So that also tells you you're looking for a number. Well, g of times f of 0, remember, is the same thing as g of 0 times f of 0. Well, g of 0 is 1 and f of 0 is 2. So this is simply 1 times 2, which is 2. Last one, f minus g of 2 is the same thing as f of 2 minus g of 2. F of 2 is -1. When x is 2, the result is -1. And g of 2 is +1. So I have -1 minus 1, and that's -2 as an answer. So that is a lot of examples on operations on functions, but including finding their domain. Next time we talk about this section, we will talk about compositions and finding their domain. Please continue the study for the test, and feel free to start on that homework if you're feeling good about it.